Now let's when we have this situation where we're given side, and angle, this is basically probably the most complicated case out of all. Um, as in some cases, more than one triangle may be formed to satisfy the given criteria, or sometimes there will be no solution. So in this case, basically we could have one solution, two solutions, or no solutions. How so? Well, remember, side angle means we're given two sides and an angle, not between the sides, but on the side of one side. Okay, so if that side, so here we're given B, we're given A, and we're given alpha. So as you can see in this case, this angle is fixed. We cannot move this side because of the angle is given. Now, if side A is too short compared to side B, then, and it never touches this side, C, then no triangle can be formed. All right. Now, another case, I want to jump down here. When this side is too long, so this way, it could either go this way to the right, like to touch the side C, or it could go in. And in this case, we're gonna have two triangles. So here's the illustration of it. So this side can go this way or that way, which will give us two triangles. Or if this side A is just right and it touches our side C perpendicular to it, it just touches just right, then we're going to have one triangle, and it's going to be a right triangle. One triangle, which is also a right triangle. So that's why it's called an ambiguous case, because any one of these options are possible. So let's take a look at one of the examples. I mean, we're going to look at a couple of examples. So here's our example number 2 in this section, and we have a triangle where we have two sides, 8 and 6, and we have one angle, which is 35 degrees. So we don't know the other two angles, just one angle and two sides. Okay, so what we're gonna do first, we're gonna use our law of sines to find one of the other angles. Okay, so I'm gonna do sine gamma. No, this is alpha. So okay, sine alpha by A equals sine beta divided by side B. That translates into the sine of 35 degrees over 6 equals sine beta, which we don't know, over side B. Again, I'm choosing the ratio where I know 3 of the components out of 4. Right? So if for this ratio, I need sine alpha A, sine beta B. So out of these 4, I have to know 3 in order to solve for the 4th one. So that's why I chose this one as opposed to sine gamma over C, because I I don't know either one of those values. Okay, so let's solve for sine beta. That's going to be 8 times sine 35 degrees divided by 6. All right. Let's put it in a calculator. I have 8 times sine of 35 degrees divided by 6. All right. So I now know that sine beta is 0.76476858. Okay. So how do I find my beta? Okay, I'm gonna take the inverse sine, right? So I'm gonna take the inverse sine of this value, 0.76476858. All right. This gives me 49.8864, so forth, right? So beta is approximately, let's say 49.89 degrees, let's say. Let's round to 2 decimal places. All right. Now, from using the arc sines from the previous chapter, from 8.3, we know that actually inverse sine will have 2 values on the unit circle. So remember that the arc sine function only gives you the angles in the first and the fourth quadrant right here. But what about the angle symmetrical to it, like maybe here? It's also an option. Let's figure out. So we're going to call this beta 1, right? What about another beta? We have beta 2 possibility here, which is going to be pi or 180 minus this angle. It's going to be 180 minus 49.89. So what is it? So beta 2 is approximately going to be that's 50. So 130 0.01 degree. That's our other option. I'm sorry, it's 130.11, not 0.1. There you go. All right, so how does that look? I mean, when we look at this picture, we see that beta is actually an obtuse angle. So it's in the picture, it's not 49.89 degrees, it's 130, right? So right here, it's 130.11. Now, where does 49.89 come in? Well, remember that we don't know the length of this side. It could actually have gone a little bit further. Like so. And then this side, which is 6, could actually turn this way. Now this angle right here is 49.89 degrees. Okay, it's the same. So the length of the side is the same. It's a 6 unit um, length. All right. So now we have two possibilities for side C. All right, and two possibilities for this third angle. So let's take a look at those possibilities. So step 2, we're gonna find our gamma. And because there's two possibilities, we're gonna name them gamma 1. If beta is 130, indeed, then gamma 1 is gonna be 180 minus 35 right here, and minus 130. So what do we have? We have that our gamma is 14.89 degrees. So a very sharp angle, which the picture does not reflect, but the math is correct. So let's find our side C according to the measure of angle gamma that we found. And we're gonna use, okay, sine alpha over A equals sine gamma over C. That gives us C is A times sine gamma divided by sine alpha. So that's going to be A is 6 sine of 1489 degrees over sine of 35 degrees. And well, that is going to be equal to approximately 2.69 units. So this side would be, so this angle is going to be very sharp, and this side is going to be very small, because the sides are proportional to the angles across of them. So our case 2 was for when beta is 130.11 degrees. Now the second case is if beta is 49.89 degrees, then let's see what happens. In this case, our gamma is going to be 180 minus 35. Still, alpha is not changed, but beta now is 49.89. Now, what does that equal to? That equals to 95.11 degrees. Okay. Now we're gonna set up our ratio in the same way that we did right here. Sine alpha over A equals sine gamma over C. And C equals A times sine gamma divided by sine alpha. Now let's plug in the values here. So the values for C going to be A is still 6. Sine 95 gamma, 95.11 degrees over sine of 35. And that is approximately 10.4 units. So now what do we have? Let's recall. We have, again, two triangles. If beta is 130.11, then gamma is 14.89 degrees, and then C side C is 14, where is it? 2.69 units, which makes sense. It's very short, right? Because as law of sine say, that the side of the length of the side is proportional to the angle across from it. So a small angle gives us a small side that's across from it. But if beta is actually 49.89, then we have a slightly bigger gamma, 95.11, and then the side across from it is going to be 10.4 units. So that's our example 2. And I invite you to try this type of a problem by yourself. So here we're looking at the triangle with angle of 80 degrees, and then the side across from that angle is 120, and another side is 121. Okay, so go ahead and try it and see what you get.